We're in a very fortunate position in that we're a first-party studio, and our aim from first party is to push platforms, to prove technology, to make the whole ecosystem better. So we're very open kimono, the saying is, with all of the other studios. Hey, we built this cool tech, it's yours. Have it. Have this. Because it makes the entire thing better.
Right.
That's not necessarily what drives the team. For us, it's about the gamers and car culture. Tires, if you go to a lot of the textbooks, first off, the textbooks don't necessarily agree. And we had to first get to the bottom of why they don't agree. Was somebody using, applying a Pesca curve incorrectly? They were interpreting their data incorrectly. So we started working with manufacturers like Toyo and then Michelin and Pirelli. And that got us one step closer to the truth. And we realized, wow, we still don't have the truth. So we really need to stop using experts and instead become experts. So by going to Calspan, they don't want to interject any opinion whatsoever. All Calspan wants to do is test. That's kind of what they're born to do. And so we would put forward a hypothesis and they would be like, nah, I don't care about your hypothesis. And what we learned was that we could actually reconcile the data. The tires do some very unique things based on how they're constructed, and the tires change year to year to year. And I don't think people really grasp this as much. That even the fuel efficiencies that are had on cars from manufacturers, so same model, but the next year they're somehow getting like 1 mile per hour better fuel efficiency. Part of that is their deal with the OEM tire manufacturer. Right. That they say, hey, I need you guys to get me 2% better fuel efficiency. So they'll either overinflate the tires, which is infrequent, that's kind of cheating. Usually they get a new compound.
Right.
But these manufacturers can do amazing things with the compounds, and that was what was creating the weirdness in the data. You need to test a lot more tires than even we knew. The way that all these tires are tested at Pirelli, at Michelin, at Calspan, was to a certain slip angle. Because you don't need to know what it does beyond that slip angle, unless you're doing a simulation.
Right.
And the cars routinely pirouette or drift or do whatever. Now when you get to that slip angle, the tire is going to heat up. And when it heats up, the gases are going to expand. So that meant creating custom tests with Calspan to control for heat and to control for the pressure that was building up. And you wear the hell out of the tire. So you can only do like 1 or 2 tests in the tire and it's done, you got to get a new tire out.
When it came to rain, there was 2 distinct things that we wanted the player to come across. First, it was going to be about the precision that's required in rain. As you know, they call rain, in racing they call rain the great equalizer, right? It's the true test of a driver's skill. So we wanted to make sure that when players got onto the track and they were going to experience not only the visuals of rain, not only the changes and subtleties of just the tarmac, but also physically simulated 3D puddles. And it's also about the tension, right? So we call it the pucker moment. When you drive over a puddle and you're like, oh, right? As you know, when you aquaplane, the tire loses. We captured our surface types. We measured an exact experience for how deep we wanted our puddles to go. Knowing some of the player types that you saw out there, it's about mastery. It's about perfecting a turn every single time. And so we wanted to make sure we recreated that exact experience. So you'll see here the way we're simulating the raindrops as they come onto the windshield. We heard our fans loud and clear, and we're going to be giving them some tools so that they can make their driving tours more professional if they want. What it's like in Yas Marina or even Daytona when there's so much light, it's like driving in the day, right? So it's the stadium light, it's the grandeur, it's the color of lights as they cross across the car. And then the juxtaposition of that is something like the back straight of Le Mans, when it's just black. And so it's honestly just you and your headlights, right? So I've got tunnel vision as I'm looking down, and 2 things. I hope I can see the car in front of me's brake lights so I can try to understand where the brake markers are. Hopefully he's taking them right. And then the other thing is the fear of what happens when you see a car coming up from behind you, and then passing by, right? It's the sound of that, right? Adding 8 cars to our car field has been crazy, right? We had 16 on Ford Smart Sport 5. Adding another 8, it's awesome to see a turn with 3 cars wide.
Since we try to drive the content at such scale, so many cars and so many tracks, we couldn't go in and kind of hand tune each material in a non-physical way, because we've done that in the past and it was always a bear. It took too much work. And this is why a lot of the industry is moving in the direction of physically based materials, because with physically based rendering, you're pulling the properties from things that people actually understand and actually mean something. And so then when you want to go and say, well, it's going to be night, or this is going to be in the wet, and you can actually tweak those real properties and have them behave correctly, and then across the whole scale of content, it just does the right thing.
Last generation, even with our AutoVista cars, which were incredibly highly detailed, it was really about texture resolution and polygons. So polygons gave you the curves, and if you wanted a more subtle curve that could live at the sub 4-inch level of detail, you needed more polygons. And if you wanted the texture resolution, or you wanted real crispness, you need a great texture resolution. Physically based materials allows us to use polygons when they're needed to actually make a shape. And they allow us to use textures when they're needed to make a crisp detail like a letter.
Right.
Scratch. Yeah.
And so even though we had really kind of high standards for where we were going with wet, it meant that by the time we had everything working together, you know, all of the bits of the atmosphere that we wanted, the water on the lens, the water on the cars, the water on the windshield, everything working together, suddenly we said, wow, this is actually, we've been able to really achieve our concept, which is really good for us. What that means we've been able to do with this generation is purpose build our tool chain and our pipeline so that we know that we want to achieve, you know, the scale that we were doing in the last generation, but with the quality that we were trying to target in this generation.